This tutorial will show how quick and easy it is to design standard rectangular or circular concrete columns using CSICOL's Quick Design Wizard. For this example, we will create a 36-inch square column with a circular reinforcement pattern. We start by going to the File, New Column using Quick Design command. On the Design Wizard form is a flowchart listing each of the basic steps we will follow to lay out and design the column. For our square column with circular reinforcing, we will simply work our way through the buttons on the wizard form to define and design the column. Start by specifying the units to use and the code. The unit selection represents a group of units. In this case, the section dimensions are in inches, the member lengths are in feet, and the moment in kip feet. For this example, we will use the ACI 318 code. The next step as we move down the list is the material definition. We will use a concrete with an F prime sub C equal to 4 KSI and grade 60 reinforcing. For confinement and cover, we will leave the default of 1.5 inches, but we'll switch to spiral for our circular reinforcement pattern. The next step is to actually define the dimensions and reinforcing in the rectangular section. We do this by clicking on the Define cross-section button. Here we can specify the width and depth of the section, as well as the rebar layout, which will be a circular pattern. Here we also specify the number and size of the longitudinal reinforcing. Clicking on the buttons with 3 dots brings up a subsequent form with additional information. For this example, we will specify 8 number 7s, but the program generates an alternate list that we could choose from as well. Next, we will indicate that we wish to consider slenderness effects. This revises the flowchart and adds the Define framing step. In this step, we are looking to define the K factors, which we can input directly for each direction, or have the program compute based on the member's framing into the column. For this example, we are assuming that the column is an intermediate story. And if we click on the 3-dot button, we can specify the EIs of the members framing into it. Again, on this form, we have complete control of the framing pattern. And if we do not know the EIs of the members, we can click on the 3-dot button. We can simply specify the member geometry, and the program will calculate the values for EI. Once the framing members have been specified, we can ask the program to calculate the K values. We need to specify the K values in the other plane, and in this case, we will simply copy the values. We are now ready to define the loading. For this example, we will consider non-sway behavior. If sway is included, additional loading parameters must be defined. The program provides a check for sway based on 3 different methods. We will use the default loading values along the x-axis. And along the y-axis, we will copy the loads from the x-axis. According to the flowchart, we have processed all steps and are now ready to view the results. We start by looking at the capacity ratios, which at 0.74 is below 1, so it appears that our section is adequate. A click on the detailed results gives us additional information, such as the neutral axis location. Results may also be displayed graphically, including the PM curves, the MM curves, and the full 3D interaction surfaces. And all the information about the column and its design may be output in an easy-to-generate report format. This concludes this tutorial.